What we have today is 16.3, integration of exponential functions, 1 over x and 1 over ax plus b. Okay, we just dive right into the integration for the exponential functions first. Okay, now if you recall, y if equals to e to the power of 3x plus 2. Do you remember that if we differentiate with respect to x, what we do is we will differentiate the index itself, 3x plus 2, it gives you 3, then you just multiply 3e 3x plus 2. Hence, if you integrate, okay, what we'll do is we will differentiate 3x plus 2 to get 3, and we'll divide by the 3, okay, and then you will eliminate, you will get back the original. Okay, so that's in a nutshell how we integrate the exponential functions itself. Okay, so now, okay, very quickly, what I'm going to do here is this. So let's do example 12 together. So part A, it works like this. If I'm integrating e 2 minus 3x with respect to x. First, differentiate 2 minus 3x with respect to x, you get negative 3. So once we have negative 3, what I get is 1 over negative 3 e to the power of 2 minus 3x plus c. So I get is negative 1/3 e 2 minus 3x plus c. I think this is quite simple. So what I'm going to do here is this. I give you something slightly more complicated, but it's not very much more complicated. So let's just try to resolve this first. Okay, so now we simplify 1 over e to the power of 9x minus 5. Then, okay, in order for me to perform the integration, this term, okay, I will express it as e to the power of negative 9x minus 5. So I get 9 over 4 e to the power of negative 9x plus 5. Then I can start to integrate. So if I integrate 9 over 4 e to the power of negative 9x plus 5 with respect to x. So what happens here is this. If you differentiate, okay, negative 9x plus 5 with respect to x, you get negative 9. So 9 over 4 multiplied to 1 over negative 9 e to the power of negative 9x plus 5. Then if I eliminate 9, what I'm left with is negative 1/4 e to the power of negative 9x plus 5, not forgetting my integration constant, plus c. Okay, your turn. Try 12. I will go through the answers with you very shortly. So do pause the video, try it out first. Okay, here. If you integrate e to the power 3x plus 1, first thing we do, differentiate 3x plus 1 with respect to x. Differentiated, you get a 3. So 1 over 3, just copy out e to the power 3x plus 1, not forgetting our integration constant plus c. This one, okay, we split it up, it becomes half, this half, times 1, okay, so this one, let me do it out for you. Half times 1 over e to the power of 1 minus x. The half remains, then what I get is e negative 1 minus x. Hence, you get half e negative 1 plus x. Or what they have rearranged it to show is x minus 1. Then, what you get here is you differentiate x minus 1, you get 1. So, you get half e to the power of x minus 1, not forgetting the integration constant plus c. Example 13. The gradient of a curve y equals to fx at any point is given by dy dx is equals to 2 e to the power of x plus e to the power of negative x. Given y equals to 3 when x equals to 0, find the equation of the curve. So if you differentiate with respect to x, you get dy dx. So if you integrate, okay, what you get is y. Hence, okay, what I can say is y is equals to the integral of 2e to the power of x plus e to the power of negative x dx. So y, okay, now 2e to the power of x. x differentiated gives you 1. 2 over 1 changes nothing. So this term, when you integrate, you get back the same thing. Now, for the other term, e to the power of negative x. E to the power of negative x, you differentiate negative x, you get negative 1. 1 over negative 1, it changes negative and positive. So this actually changes to negative itself. Hence, I will just erase this, and this gives you negative. Then, don't forgetting that every time you integrate, you should have the integration constant. Now, how do I find the value of the constant? Notice that it gave you more information. When y is 3, x is 0. So when y is 3, then my x value is 0. So 2, 3 equals to 2 minus 1 is 1 plus c. So my c value is equals to 2. Hence, my equation of my curve is this. Okay, and that concludes example 13. Now, we are done with exponential. I think you can try 13 first. Pause the video as per normal, go and try, and when you're done, unpause the video and I will go through. Try 13. Okay, now if you integrate dy dx, what you get is y itself. So if you have you integrate 1, you will get x, okay, e to the power of negative x. Differentiating negative x gives you negative 1. So 1 over negative 1, hence this symbol here changes to negative plus c. Then don't forget to solve for your c. So when y equals to 4, your x value equals to 0. So this becomes 0, this becomes 0. So your c value is 5. Hence, the equation of the curve is given by this. Now, if you recall, y equals to the ln x, differentiating y with respect to x. Take the reciprocal, remember, take the reciprocal, then, okay, you will, what I call, you take the reciprocal, then you differentiate x, okay, and then you get 1. So now, okay, what we're doing, right, is the exact opposite. Okay, so now, okay, same idea here. If, right, let's say we are going to do the integration. So if you integrate 1 over x, what you get is ln x itself. Okay, now, if I'm integrating 1 over ax plus b, so if you remember in the past, if I have y equals to ln of, let's say, 3x plus 2. So what I'll do is when I differentiate with respect to x, I take the reciprocal, okay, and then I will differentiate the 3x plus 2 to give me a 3. Then I multiply by the 3 itself. So if I am going to do the integration itself, the idea here is 1 over 3x plus 2, the reciprocal, okay, you go backwards, it becomes ln of 3x plus 2, okay, then we have the 3. So what I need to do is to differentiate 3x plus 2, you get 3, 3 over 3, you get back ln of 3x plus 2, okay, if you integrate. So you have ln of 3x plus 2. Okay, not to worry, I can show you an example now. So for example 14, okay, quite simple here. So if you have integral of 3 over x dx, so you factorize out the 3, you get 1 over x. Then integration of 1 over x, use ln x. So I get is 3 ln x plus c. Part B, okay, you're integrating 1 over 2x minus 1 with respect to x. So you take back the reciprocal, so you get ln of 2x minus 1, okay, plus c. Don't forget to differentiate the bracket and divide. So differentiating 2x minus 1, use 2, so you put a half now here. Hence, this gives you half of ln 2x minus 1. Okay, part C is similar to part B with just a bit of tweaking. So you are attempting to integrate this. Notice that the numerator is no longer 1, it's a 2. So to solve yourself some heartache, you factorize out the 2. What I get is 1 over 1 minus 2x with respect to x. So once again, when you see this pattern 1 over something here, what you do is you get back ln. So it's ln of 1 minus 2x. Okay, this 2, I will just copy it out and put it out in the front here. Now don't forget that you still need to differentiate 1 minus 2x to get negative 2. What do you do with negative 2? You will divide by negative 2 here. Hence, we put here as negative 2. So not forgetting my integration constant. So I get the negative ln, okay, of 1 minus 2x plus c. Okay, please attempt try 14. Okay, pause the video, try it now. When you're done, then I'll go through the answers. Okay, I think B and C is quite straightforward. A, you need to do a bit of manipulation. So please attempt it now. Okay, for A, the manipulation is as such. If you take 2x minus 3 over x, it can be simplified to 2 minus 3 over x, okay, which is what they show down here. So what happens here is when you integrate 2, you add in the x, you get 2x. 3 over x, okay, is negative 3 integral of 1 over x with respect to x. 1 over x integrated gives you ln x. The negative 3, just put it out front, so it's negative 3 ln x. Next one for this, 1 over 1 minus x, you take the reciprocal, so this becomes ln of 1 minus x. Differentiating negative x will give you negative 1, so 1 over negative 1. Hence, what you get is negative ln 1 minus x plus c. Same thing here, once you see this pattern, you integrate, you get ln of 3x minus 2 and plus c. You differentiate 3x minus 2, you get 3, so you divide by 3. So you get 1/3, okay, of ln 3x minus 2 plus c, which is what is shown here. Okay, now let's do example 15. So as I was speaking in class, I always say that in the questions become a bit more complex when they actually combine questions together. So one of the very common ways that the integration of the form 1 over x and 1 over ax plus b will take, right, is that they will also combine it with the topic on partial fractions. So, okay, if you can remember, okay, we need to do partial fractions first. So let me just do part 1 first, okay. So part 1 works like this. We are given 14x squared plus 7x plus 2. Okay, x over 2x plus 1 squared. First, check if the order of the numerator is lesser than the order of the denominator. So in this case, if you look, okay, the order of the numerator is 2. X and then x squared here, the order equals to 3 at the denominator. So you can begin to express this in partial fractions. Now, quick recap for partial fractions. There is a x and a 2x plus 1 squared, which is repeated here. Hence, what we get is a over x plus b over 2x plus 1 plus c over 2x plus 1 squared. I hope you remember this. Now, in order to solve, okay, there are a few ways, okay, but the first thing that we need to do is 14x squared plus 7x plus 2 equals to, we'll multiply every term by x times 2x plus 1 square. So what I get is a times 2x plus 1 square plus b x 2x plus 1 plus c times x. So I've just multiplied every term by x, 2x plus 1 squared. Now, we need to substitute appropriate values, okay, for me to actually find the value of a, b, and c. First one, I think the obvious choice is let x be equals to 0. Left-hand side, use 2, okay. Why 2? I won't explain any more after this really for the other values. 0, 0, then 2. So you get 2. Here, 2 times 0 plus 1 is 1. Therefore, here we get a. Then b times 0, the whole term becomes 0. C times 0, this whole term becomes 0. Hence, very quickly, when x is 0, my a value equals to 2. Now, the rest of it, I'm not going to work out the mechanics really. So, I think that another good value to use, okay, is we let x be equals to negative half. Why negative half? Because 2 times negative half will give me negative 1. Negative 1 plus 1 will be 0. So this term will eliminate, it will cancel out. This term will also be eliminated, it becomes 0. So I can be able to find C. So 14 times negative half square plus 7 times negative half plus 2 is equals to 0 plus 0 plus, minus half C. Okay, so if you work everything out, your C value is negative 4. Now, we got one small little issue now. We are still left with the value of B, which has not been found yet. Okay, so there are a couple of ways here. Inside the book, what they did was to let x be equals to 1. Okay, that works out. Another way is to compare the coefficients, okay, of x squared. So actually, let me see. Let me just try something. You can look at your textbook on page 109 for the method. They let x be equals to 1. I'm just going to try something a bit different here. So I'll say compare coefficients of x squared, just to jog your memory a bit. So from the left hand side, x squared gives you 14. Okay, 14 comes from here. Then 2x squared will give you 4x squared. So what I get is, then you multiply in the a, so the coefficient there of x squared gives you 4a plus 2b. Okay, where did 2b come from? Bx times 2x is 2bx squared. Hence 4a times 2b. So what we have here is 14 equals to 4 times a is 8 plus 2b. If you solve, okay, you will get the value of b is equals to 3. Your textbook provides an alternative whereby they just let x equals to 1. You will also get the same answer of b is equals to 3. Not forgetting that you need to write out the final answer itself. So what you get is, let me do the lazy thing here. Okay, can I do this? I can do this. Okay, this is equals to a is 2, so it's 2 over x. B was 3, so it's plus 3 over 2x plus 1. And C is negative 4, is negative 4 over 2x plus 1 squared. Okay, now what we're going to do here is this. We're going to use this result and we'll attempt to integrate. So what they want us to do is to integrate what we expressed in partial fractions. Hence, integrating this is the same as integrating these three terms, which is what we're going to do. So let me just copy this out again into my next slide. Okay, so I'm integrating with respect to x. So first term, 2 over x is 2 times 1 over x. So if you integrate this with respect to x, you get 2 of ln x. So I write that down, 2 of ln x. Similarly, okay, 3 over 2x plus 1. If you integrate this, okay, it can be written as 3 integral of 1 over 2x plus 1 with respect to x. So what I get is ln 2x plus 1. Differentiating 2x plus 1 gives you 2, so you have 3 over 2. This 3 comes from here, then the 2 was when we differentiated here. So the second term yields plus 3 over 2 ln of 2x plus 1. The last term, please be a bit more careful, okay? So the last term, what we are doing here is this. So we are actually integrating minus 4. Okay, just give me a moment. So the last term here will give me negative 4, 2x plus 1 to the power of negative 2. So we need to integrate this with respect to x. Okay, just focus here a bit. Okay, for this third term over here, what I need to do is I need to increase my power by 1. So I've already integrated 2 terms already. So you get 2 ln x plus 3 over 2 ln of 2x plus 1. Okay, I forgot the plus c. Okay, plus c. So what I get is negative 4. So negative 2 down here. First, what I do here is negative 2, my power plus 1 will give me negative 1. Then I divide, okay, by my new index. Then don't forget to differentiate 2x plus 1, which gives you 2, divide by the 2 itself. Then all the integration yields a plus c over there. Now, if I simplify everything, what I get is 2 ln x plus 3 over 2 ln of 2x plus 1. Negative and negative gives you positive 4 divided by 2. It becomes positive 2. So it's plus 2 over 2x plus 1 plus c. Okay, and that concludes, right, my example 15. Now your turn to try 15. First, do the partial fractions. Okay, I just give you a very simple clue. I mean, if you can see this, it actually should give you a over x plus 3 plus b over 2x minus 1. Then you perform the integration itself. So try 15. First, part 1, as I said, then you multiply every term by x plus 3 to x minus 1. You use this. So the obvious choices is to obtain a, we let x be equals to negative 3 such that this term will become 0. So a is negative 1 over 7. Similarly, to make this term become 0, we let x be equals to half so that this becomes 0. So half plus 3 times b equals to 1. So b you will yield 2 over 7. So the partial fractions yielded will be this. Now, hence, fine. So if we were to integrate what we did earlier, so if you integrate 2 over 7, 1 over 2x minus 1, it yields ln 2x minus 1. Differentiate the 2x minus 1 and divide, so it gives you half. So the 2 and 2 will eliminate, give you 1 over 7. Similarly, for this term here, negative 1 over 7, you factorize it. Integrating this yields ln of x plus 3. You differentiate x plus 3, you get 1. So 1 over 1, no change. Hence you get negative 1 over 7 ln of x plus 3. Then not forgetting your integration constant plus c. And if you leave it in this form, it's perfectly fine. What the book actually does is to combine using the laws of logarithms to get this. It's also completely fine. Okay, and that